No other company can provide the critical insight across industries that Autodesk can. Autodesk tools are used in nearly every industry where things are designed and made, from manufacturing, media and entertainment, natural resources, infrastructure, architecture and mechanical, electrical and plumbing, otherwise known as MEP. These industries face similar challenges and need similar capabilities. We're seeing a convergence of how things are designed and made across all of Autodesk's industries. Progressive construction companies are operating more like manufacturers by prefabricating and assembling things like apartment units, exterior walls, and MEP services. Media and entertainment firms are behaving more like car brands by planning and pre-visualising entertainment properties long before production, just like an automotive manufacturer will plan and develop a concept car. Why are we focused on this? Because more is inevitable. The global middle class is growing faster than at any time in history. 400,000 people join the middle class every day. With this increasing urban population comes a demand for more of almost everything: housing, cars, smartphones, highways, hospitals, new and repaired infrastructure of every type. Less is a reality. The more we make, the fewer resources we have left. Less limited natural resources, less skilled labour to go around. We also waste a lot. Today, 30% of global waste comes from construction. We have an incredible opportunity to do better with automation. For decades, automation has helped us offload tasks and optimise processes. This new relationship that combines human innovation and computer automation is helping people imagine and realise new kinds of design ideas. Automation is changing the way we make things, how we make them, and how we work. Things, whether products or buildings, are becoming better suited to human needs, more customised, more configurable, more connected, and ultimately more valuable to us. In the realm of making, robots are moving from the production line to the construction site. 3D printing is going from prototyping to production quality. We're now capable of making things of increasing complexity and fidelity. Work is changing as the processes of design and making converge across industries, and industries themselves are converging. Construction is becoming more automated, more like manufacturing with prefabrication and module components. Teams and supply chains are increasingly connected. Automation gives us the opportunity to co-create with computers and do more meaningful work. It's changing what we're capable of making. Double the number of city dwellers in the next 30 years. See 200,000 people migrate to cities every day until then. Build an average of 13,000 buildings a day between now and then. What impacts your ability to satisfy that demand? The following 4 items. It will be very difficult, if not impossible, for the industry to satisfy this need for growth without making investments to improve productivity. The challenge that we are facing today is that industry is not set up for success in terms of production, collaboration, and efficiency. We are typically operating in a fragmented way, with low margins and high risk, as well as a lean investment in emerging technologies. The design and construction industries could save upwards of $1.2 trillion per year by moving to fully digital processes. Let's look at how BIM adoption will enable to solve these challenges moving forward. The solution to the industry's challenges, as well as the business challenges of individual construction firms, is building information modelling, or BIM. BIM is an intelligent 3D model-based process that equips architecture, engineering and construction professionals with the insight and tools to more efficiently plan, design, construct and manage buildings and infrastructure. With BIM, you can improve project understanding and decision making, share and use the same consistent data across the project lifecycle from your desk or in the field, respond quickly to change with processes that are smarter and faster. This is the path we are on, Connected BIM. Connected BIM is building information modelling plus the power of the cloud. It's a cloud-enabled, intelligent, model-based process that unites the design, build, and operate segments. Thanks to BIM, we're already seeing some incredible changes in the construction industry and several trends that are tightly connected to how teams are using technology. Some of these include owners realising the benefits of BIM and the associated project savings, leading to more BIM mandates and the advancement of new standards supporting BIM maturity, like ISO 19650, formerly known as BS 1192, the National BIM Standard, and the level of detail requirements across the world. As optimised designs include greater detail, there is an explosion of data produced by BIM projects with higher fidelity at a greater frequency than that of 2D information, especially with increased computational power. Technology is removing barriers to collaborate across distances. Teams are assembled across different offices and geos representing larger talent pools. These trends are causing engineers to extend their services downstream and fabricators and installers to extend their services upstream. Teams are relying more and more on data to communicate. But these drivers are causing several business challenges too, especially for the construction industry. Some of the challenges we're hearing include increasing project complexity creates inaccurate estimates with lack of design information. Detailers need a faster and more seamless way to collaborate with the design team. Especially during the detailing phase, data is often disconnected from the rest of the design team, causing a disconnected workflow. Lack of skilled engineers, detailers and shop workers impacts quality even with global teams, puts greater pressure on fabricators to automate their lines to increase output. Lack of coordination on job site creates waste and inefficiencies. Fabricators are being asked to use technology to provide greater insight into how they will deliver and install. We believe that Autodesk's BIM solution for construction can help you to overcome the business challenges you are facing by connecting project data across the life cycle of your construction project. This will allow you to increase profits and maximise your existing resources, meet the BIM requirements that are becoming increasingly common across the globe, and collaborate more effectively with your stakeholders. Our portfolio of BIM technology supports end-to-end workflows across construction disciplines from the project's conception to completion. With Autodesk tools, you can begin BIM workflows even at the conceptual stage of engineering design. Both conceptual design and analysis tools are built right into our BIM authoring applications. In addition, our solutions are interoperable and help you move from one phase of the asset's delivery process to the next, so that you can seamlessly collaborate from your design through to the construction phase of your project. During the construction phase, fabricators can better plan and optimise fabrication for the job site. For example, they can drive workshop processes using model data, plan steel sequencing, verify field as-builts and track materials with BIM 360, and finally share as-built models with contractors and owners. To do this, you can use Revit and Navisworks Manage for concrete or Advanced Steel and Navisworks for steelwork. Note that we know it is important that our technologies connect to your other critical software that are important to your business, like for steel connection design or for fabrication production. This has the ability to export numerical control or NC files and other reports that feed the fabricators. Manufacturing Management Information Systems or MIS, Enterprise Resource Planning or ERP, and fabrication machines on the shop floor. In recent years, Autodesk has formed tighter partnerships with MIS organisations like Steel Projects and FabSuite to more deeply integrate Advanced Steel to fabrication management processes. Advanced Steel is also integrated with Strut MIS, FabTrol, Romac, and Advanced Workshop MIS solutions, as well as with all the leading steel machinery providers. What we are demonstrating here is the ability to export an advanced steel model into Navisworks. All the object properties will import as well. Navisworks gives you the possibility to review your model for accuracy, such as calculate distances, areas and angles through various measuring and markup tools. The red line tools panel enables you to mark up viewpoints and clash results with red line annotations. When it comes to planning the project, the timeliner feature can help simulate the erection of your design. Once scheduling tasks and rules are assigned to objects in your design, Navisworks will allow you to perform a 4D simulation of your project, complete with a Gantt chart, which provides a visual representation of your schedule. Here, we can see the coordination of clashes for reinforcement design between Navisworks and Revit. Cloud-based collaboration tools are enabling design teams to work in new ways on BIM projects. By centralizing project data in the cloud, firms can accelerate design delivery by enabling teams in multiple offices, even on different continents, to concurrently work and share models. In addition, this technology makes it easier for structural firms to work fluidly on design build, design assist, and integrated project delivery projects. AEC Collection customers can use a combination of AutoCAD and Revit-based deliverables with BIM 360 docs to deliver accurate documentation for all project members. In this workflow example, a structural precast detailer has an existing library of AutoCAD details that they would like to leverage on a project that requires Revit. Using BIM 360 docs, they can collaborate with Revit users on the required precast designs and communicate all necessary precast connections in the .dwg file format. The AutoCAD designs can be leveraged by Revit users when modelling a detailed design phase LOD in the BIM environment. These details can be attached to the final documentation too. Revit is a BIM-centric solution for the reinforced concrete industry to connect concrete design and detail into fabrication. It provides tools for detailers for modelling 3D concrete reinforcement bars, creation of shop drawings, and bending schedules in the advanced BIM environment. The structural precast for Revit extension provides Revit users access to powerful tools for automatic rule-based segmentation of precast structures, automatic reinforcement, shop drawings, and CAM files. The structural detailer can use the Publish Settings tool in Revit to select views and sheets of the model and publish them to the cloud. Once all 3D precast designs and drawings are created, the structural detailer can share them with the project manager via BIM 360 docs. Once all published sheets and views have been extracted, they're ready to be viewed by the project manager. BIM 360 docs integrates the entire project workflow from design to construction across one common data platform. In the first case, reinforcement bars surrounding the doorframe need a larger diameter. To ensure that any errors found in the review process are addressed, a trackable issue complete with a detailed description of the problem and a recommended completion date can be assigned to a specific project member, in this case to the structural detailer. The second issue shows that there are missing grout tubes in the precast wall. The third issue identifies missing reinforcement bars around the wall void. BIM 360 docs can also create markups. When a user adds a markup, it is added to the document's markup history. It can be tracked by the revision history as the team responds and adds additional markups. By default, markups are private, but they can be set to publish via the markups panel and seen by all project members. In our example scenario, a precast detailer receives an email notification with a link to the issue that was assigned to them. This link instantly brings them to their BIM 360 Docs project and to the correct view. The viewer is automatically zoomed into the issue pushpin. They can get a very quick understanding of all the issues that should be addressed. Fixing issues with Dynamo and Revit is very useful. In this case, the structural detailer is using Dynamo Player within Revit to automate the process of adding grout tubes to the precast walls. Once the updates or changes are completed in Revit, the structural detailer can respond to the project manager using the same tracking tool that keeps an up-to-date record of the issue's progress. Confirmation of the issue's resolution can be done by using BIM 360 Docs Compare feature that visually highlights exactly what has been modified. BIM 360 Docs has an integrated change visualization that lets users compare the changes between two selected versions of the project. The summary provides a quick accounting of the changes contained within the new version of the project. The number of changes within a list may vary when filters and search criteria are applied. BIM 360 Docs users see color coding that shows how information is changed. The added, removed and modified buttons act as a toggle to hide or show the results from the list. At this point, the issues can be closed, and the issue's history is kept in the BIM 360 Docs environment where everyone on the project team can see who was involved in its resolution. BIM 360 Docs combined with Revit and Advanced Steel in the AEC Collection can be helpful for coordination between design and detailing teams on a project. Once the steel structure containing steel framing and columns has been modelled in the Revit environment, the structural engineer can specify connection details by placing generic connections and supply information about the desired connection. Using BIM 360 Docs, the structural engineer can upload the Revit model and create an issue that they assign to an appropriate member of the structural team, along with a recommended due date. They can even attach a schematic drawing of the steel connection to provide more accurate information. The steel detailer gets the notification through an automatic email. By clicking on the View This Issue button, BIM 360 Docs gives direct access to the issue and shows where it is in the 3D model. The issue can be reviewed and the Revit model can then be downloaded. Generic connections can now be replaced by parametric steel connections, where steel components such as clip angles and bolts are automatically inserted and configured as defined by the structural engineer. Revit offers a comprehensive library of automatic parametric steel connections, enabling connections to be modelled with a higher level of detail. Schedules with accurate quantities and detailed engineering drawings complete with dimension and tags, where steel connections are represented in 2D and 3D views, are generated automatically out of the 3D model. The Revit model can be shared with other project members by using BIM 360 Docs. Sheets and views are automatically extracted for the project team to review. Now that steel connections have been added as requested, the issue can be answered. The structural engineer can review the final Revit model and close the issue. Now it's time to create an issue for the steel fabricator and give them access to the Revit model so that they can create deliverables to create the structural steel fabrication. By simply exporting and importing the structural steel model, the steel fabricator can have access to the 3D model in the advanced steel environment. By leveraging one of the ready-to-use drawing styles, shop drawings are generated with the attached parts dimensioned and labelled automatically. NC files are generated to drive CNC machines at workshop. These deliverables can be shared as .dwg or PDF files on BIM 360 Docs. Satisfied with the outputs, the steel detailer closes the issue in BIM 360 Docs and the structural steel fabrication can now start. Aggregate your data using Navisworks, allowing you to use over 50 different file types. from all major software vendors. Enable collaboration across disciplines by interdisciplinary coordination and constructability reviews. And manage risk with automated clash detection and reporting. This will result in reduced site errors and emissions. (4D) modelling allows stakeholders to visualise construction over the project duration to identify potential spatial and temporal conflicts in schedule. Adding a cost component to the process creates a fifth dimension, making a 5D model. Such 5D engineered models allow stakeholders to evaluate costs and model cash flows for each phase of construction.